Today we're going to talk about experimentation on human subjects, also known as clinical research. Experimentation has two goals. On the one hand, if you're going to test a medicine, the first thing you want to know is whether it's safe for human beings. So safety is the first goal. Secondly, you want to know if it works. This is important because any medicine strong enough to do good is likely to have some side effects for at least a few of the people who take it. And you don't want to expose patients to those side effects unless the medicine actually works. So efficacy is important too. Now, this is not so easy to prove because of something called the placebo effect. This is the kind of, you might think of it as a kind of suggestibility. If you give people a sugar pill and tell them it's medicine, there's a fair chance their condition will improve. It's a strange phenomenon and very confusing for doctors. They often report success with medications that in fact don't work at all and that fail in a serious experimental proof. So how do you find out? How do you get around the placebo effect? Well, there is a way. It's called a double-blind controlled experiment. The idea is you give some patients the real medicine you're trying to test, and you give others sugar pills or something comparable. But you don't tell the experimenter who has what. So they report the results, and then you open the envelope, and in it they find out if the people who improved, in fact, were improved by the medicine or simply enjoyed the placebo effect. This eliminates suggestion for both the patients and the experimenter. Subjective bias no longer plays a role. If you find out that, say, 10% more of the people who took the medicine recover than those in the control group, that's a good sign. You then call in a statistician who will help you figure out if your experiment involved enough patients for a 10% improvement to be a proof of something, because it could just be an accident. So there's quite a bit of complicated operations going on here in a controlled experiment, but the result is that you get reliable data. And this is important to us right now. Think about what happened with COVID-19 and all the hoopla around hydrochloroquine. That was supposed to be the miracle cure. Donald Trump said so. He bought millions of pills to give to everybody. It turns out that several controlled experiments were done, and it proved to have no efficacy at all and was not entirely safe either. Well, this leads us then to a first dilemma. Doctors are supposed to represent the interests of their patients and no other interest. They all swear the Hippocratic Oath, which says, first, do no harm. So the doctor must look out for the patients above all. But medical progress requires experimentation, and you can't do an experiment simply in the patient's interest. In fact, experiments mainly serve society, because most of them fail and some of them harm patients. So there's a potential conflict of interest here. The doctors engaged in the medical experimentation are not actually primarily concerned with their patients. Now, some dramatic examples of this inspired a lot of concern. After World War II, it was discovered that the Nazi doctors were doing horrible experiments on people and sometimes killing the subjects without any concern about their well-being. Experiments were done by doctors in the United States too that often were not really in the interest of the patient, without the patients knowing that they were involved. This is the case in the Willowbrook experiments, which I've given you a text on. In 1966, the Food and Drug Administration issued some rules under which experiments had to be done in such a way as to protect patients' rights while also serving society's interests. There are quite a few aspects to this, but the two main ones that interest us are first, informed consent. The patient has to know they're in an experiment and agree to it. And secondly, a limited distribution of unproven medications, simply to those patients involved in the experimentation. Here's an image that shows the human subject as a little toy, a little plaything of the medical profession. That's the problem that the FDA regulations was supposed to resolve. But there's a second dilemma that arose from those regulations. There's three main types of illness: acute illnesses, like the flu; chronic illnesses, those are the ones that last, sometimes for life, like multiple sclerosis; and fatal illnesses, those are the ones that kill the patient. Now, medicine tries to address all three classes of illness. The acute ones you hope to cure with a pill of some sort or some other intervention. The chronic ones are by definition the ones you can't cure, and for those you're supposed to care for the patient, that is to say, make their life easier, provide them with symptomatic relief of some sort, and generally help them along. And then there are the fatal illnesses. Care is not very helpful for people who are dying, and curing is out of the question. So what are you going to do? Well, there's definitely a bias in modern medicine toward curing. That's where it triumphs. And doctors prefer to be engaged with acute illnesses they can cure rather than chronic ones they have to comfort the patients with for life. In the case of fatal illnesses, there's a kind of desperation. Doctors have even been known to tell patients to just go home. In this context, patients with fatal illnesses have begun demanding access to experimental treatment. It's at least something. Maybe it doesn't actually have much likelihood of curing them, but at least it engages them in the medical system where they can hope to have some care. Doctors have been reluctant to accede to this request. Why? Because they think it gives false hopes to patients. Most experiments fail, so why would you want to get involved? And then there's also the question of whether the fatally ill patient can give consent. Maybe they're still conscious and able to think and clearly and talk, but still they're under a kind of pressure which is unfair, the pressure of a fatal outcome. So here you have a dilemma between paternalism on the part of the medical profession, protecting patients from false hopes, and the autonomy of the patient, who has a right to demand treatment of some sort. The AIDS epidemic brought this to a dramatic climax. In the beginning, there was no treatment for AIDS and no cure. In the 1980s, a diagnosis of AIDS was a death sentence. Now, most of the people who had AIDS were gay, and they were already politically organized and effective. And so they were not like most patients with fatal illnesses, isolated and politically weak. These patients could protest. They could make a fuss and force the institutions to listen. They resisted the limitations on access. Every AIDS patient thought they ought to have a right to participate in an experiment. And they resisted the experimental designs. Some of these designs sound really inhumane when you describe them now. There were some experiments that required that the patient never have been in an experiment before, which meant that if you were a patient, you had to gamble. Was this your one shot at hope? That seems like a terrible situation to put patients in. There were few slots, so most of the patients couldn't get into an experiment. The ones who didn't like the idea that there were controls, because they figured they only had so much time, and if they spent it taking sugar pills, It wasn't good for them. And since these patients were pretty hostile to the medical institution, some of them would go to labs and get the pills given them by the experimenter tested to find out if they were taking a control. And if they were, they'd just disappear, which ruined the experiment. The patients organized. They had an organization called ACT UP, which intervened on their behalf with political protests. They even went to medical meetings and tossed blood on the doctors, and they rejected controls. There was a big fuss. But after a while, the activist leaders began to realize that they needed the doctors, they needed the experiments, they needed evidence that something worked. And so they began to study up, and they joined the committees of scientists in order to redesign the experiments. And out of this came experimental designs that were more humane, and a rule from the Food and Drug Administration in 1989 offering compassionate participation in experiments to patients suffering from fatal illnesses. This meant that there were no longer limitations on who could get into the experiment. Doctors could use a medication that was under experimental review before the results of the experiment were known. So here's an image of the ACT UP demonstration. You can see on their sign the slogan, "Silence equals death." Well, some lessons came out of this. This was a democratic intervention by patients into a very sophisticated and complex technical system, the system of medical experimentation. They acted on the basis of their interests, what I would call participant interests. They're participants in a medical institution, insofar as they're themselves and they're patients, right? So they're sick, they belong to the institution, but they have very few claims that they can make within that institution. And so they have interests that are not attended to. And those interests motivated them to interact with the scientists and doctors to change the institution. They studied the science, they worked with statisticians to change the procedures, and they positioned patients as informants rather than guinea pigs. This is realistic. Those patients who had their their placebo control tested were refusing the role of guinea pig. They wanted to be informants, people who were actively participating and giving information to the doctors. So there's two sides then to this intervention by the patients. On the one hand, there's an ethical dimension, which is discussed in my chapter on experimentation, and there's a scientific dimension, which Stephen Epstein discusses in his article. So I look forward to your comments on these articles, which should concern us all, since we are now waiting impatiently for the results of the experiments made on the vaccines for COVID. Okay, let me generalize from this story. First, you can see the role of experts is essential. Obviously, we're living in a society based on expertise. Everything around us has been constructed in some way in accordance with scientific or technical knowledge. And we just mostly live with it and take it for granted. The AIDS patients ended the silence of the users, the silence of the ordinary people who simply live with the technologies. They called accepted practices into question on the basis of their unattended interests. We can think of this not so much as a political conflict, or maybe it's a kind of conflict, but it's a conflict that intends a dialogue. The patients, and this also applies, for example, in the case of environmental protests, weren't trying to overthrow the experts, but to get them to pay attention, to move from conflict to communication. Conflict was necessary in order to get the experts to acknowledge the problem, to put the problem on the agenda. But the conflict was not absolute. It was an attempt to change the technical codes under which the experts were working. So I think of this as a problem in rationality. What the protesters were trying to do was to establish communication. They did so in terms of ordinary ways of speaking, thinking, and acting. They're not experts, so they used ordinary language to articulate their interests. Meanwhile, the doctors they were addressing were operating in terms of a technical language in which they were trained. But there's some shared terms. After all, most of the terms in the technical language derive originally from everyday language. They're just refined versions of words and concepts that everybody knows. Take the case of the word treatment. For doctors, treatment means applying medical knowledge. But patients think of treatment in a richer way, not only applying medical knowledge, but also showing concern, being helpful. When you go to the doctor, you are expecting concern and not just a technical intervention of some sort. So the problem of the protest was reconciling the meanings, bringing the doctors to attend to the need for concern of the patients by designing the experiments in such a way that they showed concern. This meant a kind of translation of the everyday understanding of the medical relationship by the technical personnel into a new mode of technical practice. So this takes us to a final conclusion about innovation. Some innovations respond to underrepresented actors. Case in point, it's the AIDS patients. They notice the bias of existing designs, the ways in which those designs have excluded them and their interests and concerns. The needs of groups excluded from the original design process need to be brought into the design process. So these new actors stimulate new ideas, new ways of doing things. This is a kind of technical democratization that involves bringing new actors into the equation. And we see this not only in medicine, as in the case of the AIDS patients we've discussed here, but also in environmental protest. Consider climate change, for example, which is about, the protests are about forcing on the authorities a more rapid response to a catastrophic flaw in our industrial society. And these protests appeal to the experts who actually design the systems to get on the ball and make some changes. They appeal to the corporations and governments that give the experts their marching orders to change their approach. And this is what I would call a democratic intervention into technology. We'll see more of these as we move along in the next lecture.